What's up, guys? Welcome back to the channel. Today on this video we will be doing the logarithmic logs derivatives. I hope you guys are ready for these ones, because this ones there's a lot of information that I'd like to share with you guys in order for you to understand what is happening here. But before I do that, I just like to say, guys, if you are new to this channel, remember I have done some videos on trigonometric. I've done some videos on trigonometry, limits, and also some derivative. In fact, I've done exponential derivative, standard derivative, and deriving from the first principle. If you want to watch those videos, you can go to the playlist of this channel. Now on this one here, guys, we'll be doing the formulas of the logarithmic derivatives. I hope you guys are ready for this, because there's a lot of information here, and I'm hoping that you have a pen and paper to take notes. Now, before any wasting of time, let's just go straight here. We'll be doing the derivative of two logs here. So we have two types of log. We have a standard log. For example, let's say we have log with the one that has the base of maybe let's say a, and then this is the one that we're used to. And we have natural log, which looks like this. So we call these ones natural logs or Neperian logs, guys, right? But natural logs is way much easier. So this type of a log here, the natural log, you can actually change it if you feel like you're not comfortable with it. But when you change it, you can say log e x. Now some of you may wonder, why do we have e as a base here, right? What you need to know is that the natural logs, guys, the natural logs, they always have the base of e, but we don't write it because it is implied that you know that. Okay, just like our standard logs. Remember our standard logs, if we have log like this, we know that the base is gonna be 10. So we don't write it because we assume that you know, you've been taught. If you haven't, then I'm teaching you right now that the natural logs have the base of e, and the standard log have the base of 10. All right, so when you move from natural log to natural to the logs that are base, the standard logs is going to be log base e then x. You guys understand? I hope you do understand. Now I have to erase this. I hope you took some notes here, because I am going to erase this. I'm kind of gonna need this space. Okay, all right, fine. Now let's do the formulas. Now when we derive the logarithmic, when we do the logarithmic derivatives, we are going to use some formula. So I hope you guys here will pay attention. So we're going to start with the standard log. So let's say maybe we have a log like this, right? And then the base here is a, and this is x. Now when we find the dy dx, the derivative here, the formula, or the formula that you're going to use to derive, basically it's supposed to be 1 over x, then natural log, then a. Now let's just pause, let's just stop here. You see the base of the standard log, when you derive, it comes here, guys, always. Do you understand, guys? The base here, when you derive, it comes there always. So do not forget that, guys, right? And then you can continue, and you can do this if you want to, just in case you come across this. Don't be surprised. This is the same as log. Now if you want to change from natural log to base log to standard logs, so don't forget that our base is going to be e, and then we're going to have x. Now let me just write here so that you guys, you don't forget. Let's just do a here, and then this is going to be log base e, then it's going to be a. You guys see? Now that's how you move from natural log to the standard log. All right, now this is when we have this type of a problem. What about when you have y, right, and then we have a coefficient of log? Let's do it here, guys. The coefficient of log, let's say the base is still a, and now we have x. So we have to find the dy dx what about this one here? Now we still want to do the very same thing, but this time around the k, which is the coefficient of log, is going to be on the numerator there, and then we continue write our log x natural log a, and then you can continue here and write k, and then you say x, then standard log. Remember, now you are changing from natural to standard log, then a, right? Be careful, guys, because this is a common mistake. Some of you might put x here, right? And then remember that is supposed to be a. Okay, now let's continue. How about when we have now we have y, and then we have log, right? The standard log with the base of a, and then now we have x to the power of n. How are you gonna do this one when you find the derivative? So now this is gonna be like that, guys, right? Let's continue. Now in this case, we're gonna have n on the numerator, our exponent there of x, and then we continue have x, and then we have natural log a. Some of you can continue and write n, right? And then you say x, then you say log the standard log, then base is gonna be e, then that is gonna be a. That is also fine. Now how about now when we have almost everything? Let's say we have this one here where we have coefficient of the log, and then the base here is a, right? And then the what is this? We have x as well, and we also have n, which is the exponent of the x there, right? So when we derive this, how are we gonna do this? Really, it's not that difficult, guys. So this time around, it's gonna be n multiplied by k over, right, over x natural log a, right? Just close this, natural log a. But then if we continue, remember, you can say n multiplied by k over x, then standard log. Remember, now you're changing base e, and then e. So this 1 2 3 4, these 4 formulas, we're gonna use them whenever we derive this type of a log, the standard log, guys, right? We have to use these 4 formulas. Now if they give you something that is different, probably you have to simplify using the logs law in order for you to derive. Now that we are done with the standard logs, now how about when we derive the natural logs? All right, let me just create more space here because I need to click the pen here. All right, we are fine. And it's closing. Okay, now let's erase this, guys. Can we erase this for now? Let's erase this for now, and then let's start with our standard log. Okay, let's do our standard log, guys. Our natural log, I mean. So I'm gonna draw a line here for the natural logs. So this side here will be doing the natural log. So when we derive the natural log, obviously you're gonna be given natural log, then you have x there. So the dy dx for the natural log, really, it's so simple, guys. It's gonna be 1 over x, and that's it. Whenever you have y is equaling to natural log x, then it's gonna be like that, right? All right, so let's continue. What about when you have y, and then we have the coefficient, which is k now, and then we have natural log, then we have x? How are you gonna do this one? Again, here the dy dx is gonna be k, and then over x. You guys see? Simple, simple. Would you agree? And then what about when we have now y, and then we have natural log, and then we have x to the power of n? How are you gonna do this one, right? So when you do this one, obviously it's gonna be y dy dx, and then when you do this one, this exponent, which is n, is gonna be on top here, over x. Yeah, these ones are not that difficult, guys. It's easy to remember them. What about when we have now everything just like the other one? Now we have the coefficient of natural log, and then we have x to the power of n, and then we have to find the dy and dx. So this one is going to be n multiplied by k over x, and that's it, guys. That's it. There's nothing to it. So guys, all I'm trying to tell you guys is that if you can remember these equations here for both the natural log and the standard log, it's going to be easy for you to derive the logarithm, the logs, by the way. Okay, it's going to be easy for you to do the logarithmic derivatives. All right, guys, so I will stop here, and on the next videos we will be applying these equations. So subscribe to the channel so that you can see those videos where I apply these equations here. So also do not forget to share to your friends when you find this video useful, and don't forget to comment if you have any questions, or if you want to add something, comment as well. Thank you very much, guys, for watching. Until next time, cheers.